Hello everybody, it's Mr. Ray here. I hope you're having a good day. We're going to continue on with our grade 10 applied math course. We're going to start a unit entitled Linear Equations. Linear equations is actually a very important skill that you'll need in grade 11 and 12. And I'm going to attempt to teach you some methods that hopefully make sense, that allow you to continue solving equations of a more difficult level once you get into higher grades in school. So I'm going to start off with a few definitions. Okay, so an equation, if you remember the video we did at the beginning of the course on math as a language, we talked about things like terms and expressions and variables and constants. The last thing I think we talked about was an equation. An equation, it's very easy to determine if something's an equation because it has an equal sign in between two math expressions. Okay, and by expressions, it could be as simple as something like x equals 2, or it could be something much more complicated, which we'll see. Easy to identify, and the thing we do with equations is we solve them. The verb we use with equations is always solve. Solving has a very important meaning. It means, if we look at the definition here, solve an equation means we find the value of the variable that makes the equation true. So the equation, if we go back to what it might look like I said, the equal sign in the middle, it's going to be using one variable or letter. Usually that's going to be x, but it could be any letter. You may find that letter is used more than once. You might have an x on both sides, but the goal is still the same. What's the value of x that makes this thing true? And pretty much 99% of the cases, you're going to see that there is a solution, and there's only one solution. So I don't think we'll have any examples in this course, this unit, where there isn't just a single solution. So that should make it a little more straightforward, I think. Once you get to more difficult equations next year, you'll see that, well, maybe you have maybe you have two solutions, maybe you have none, maybe you have one. Okay, so it gets a little more complicated. But for this year, it's always going to be one solution, which means there's only one value of x, or whatever variable we use, that makes the equation true. This is a very important definition. It's pretty much always the first question, or a question, on any test I do in this unit. Just make sure you understand, and that's going to be true. This definition will hold for any type of equation. We're only looking at linear equations in grade 10. Like I said, once you start doing other equations, this definition still passes the test. It still means the same thing. Okay, now there's going to be a few concepts, a few ideas I want to teach you about how to think of an equation, but the tools we use to solve equations is all based around what we call opposite operations. Another word for opposite operations would be inverse operations. It means two types of math operations that are opposite, that undo each other. For example, if adding and subtracting, those are opposite or inverse operations. If I add 2 to a number, then I subtract 2, I'm back to where I started. So subtracting 2 in that case undoes adding 2. And we also have other types of opposite operations. Adding, subtracting, and multiplying, dividing are also opposite, and those are pretty much the only ones we're going to need to use in grade 10. So always think about how do I undo what's being done, and we'll get to something more concrete on that later. Okay, you might also hear the expression isolate a variable. So if you think about what isolate means, it means by itself. Isolating means get something by itself. So isolating a variable means we want to get the variable all by itself on usually the left side of the equation, and then on the other side of the equation we'll have a number. So we'll have something, maybe when we isolate the variable we get something like x equals 4. Okay. Now by isolating the variable we've also actually solved the equation. We've figured out the value of x that makes it true. So solving an equation and isolating a variable basically have the same ending. We end up with something like this. Okay. All right. Now, I've got this beautiful diagram down here. I'm going to kind of zoom in it. I'd like to talk about what we've got here. So if you look at the main picture here without the little labels, we've got one of these old-fashioned looking scales. It's got it's got a left tray that's hanging from this arm, a right tray hanging from this arm. This is the same arm. And if we use this to weigh things. In the old-fashioned days, we'd put something on this tray that we want to weigh. Then we put some predefined weights on the other side. And what we want to have happen is the two trays are level. They're, the scale is balanced. Okay. And when that happens, that tells us that this unknown package over here, whatever we're trying to weigh, has the exact same weight as what's in this tray. So that's what they used these trays before, but it's actually a very good analogy to equations. So when you have this scale, you've got a left tray and a right tray. When we have equations, for example, if we had the equation 3x plus 1 equals 16, I could kind of bring this equation down to the scale. As on the left side of the equation, I put into the left tray, and the right side of the equation 16 I put into the right tray. Now the fact that it says an equation equals means that at that moment, right now, these two trays are balanced, which means they have the same value or the same weight in terms of what scales are used for. Now if I want to do anything to this equation or this scale, here's the most important rule. If I take away anything from this side, you can imagine the tray, all of a sudden, this side now becomes lighter than this side, so the trays will tip up, and they're no longer balanced. If they're not balanced, then the equation's not equal. So that tells me that anytime I do one thing to one side of the equation, or tray, I have to do the exact same thing to the other side. Otherwise, the scale or equation won't be balanced. So I can do a number of things. In terms of math, I can add something to both sides. I could add 4 to both sides, still balanced. I can take away 10, still balanced. I can multiply both sides. For example, multiply both sides by 2, it's like doubling. Okay, and if I do that to both sides, it's still balanced. Or I could maybe divide it by something, divide both sides by 3, and basically it's still going to be balanced. So we have to keep that in mind as our golden rule for solving equations. Anytime I'm solving an equation, I have to do the same thing to both sides of the equation. And we'll talk about how we solve it, but that's the main key to how we solve an equation. Okay, so I've kind of talked about this here. The best way to think of solving an equation is compare it to a scale with trays. See the picture below. The left tray is the left side of the equation, the right tray is the right side of the equation, and the equal sign in the middle means the two trays are balanced. Okay, as soon as it's not balanced, they're no longer equal. But when you start off with an equation, they are equal, and it's our job to make sure that it keeps on being equal. Okay, and then this kind of repeats what I just said. Since an equation is like a scale, the most important rule is that whatever you do to one side of the equation, you must do the same thing to the other side of the equation. If you don't do the same thing to both sides, the trays won't be balanced anymore, and the equation won't be equal anymore. Okay, talked about that. Now, here's an important thing about solving equations, and it's kind of a bad habit that a lot of teachers give math students in usually elementary, middle school, and sometimes grade 9, is using the word or the verb move. And I hear lots of students, when we're solving equations, they say things like, I'm going to move the 2 to the other side. For example, they might say, I'm going to move the 1 to the other side. Well, using that language tells me I'm removing 1 from this side and I'm placing it over here. If you think about the scale, if I remove the 1 and then move it over here, well, that's not going to be balanced anymore. I didn't do the same thing to both sides. Okay, so please avoid using the word move. I want you to use words like, I'm going to add something to both sides, or I'm going to subtract something from both sides, or I'm going to multiply both sides, or divide both sides by some number. Okay, that's the communication, the sentences that I want you to be using when you talk about solving an equation. Okay, now we'll get into the actual mechanism of solving. You've kind of got the main ideas about the rules. Now, once you solve an equation, like we talked about here, we get something like the variable, in this case x, is equal to a number. That's our solution. Okay, well, how do you know that that's right? So the best way to check a solution to an equation is to substitute the solution into the original equation. And then you figure out what the left side is equal to, what the right side is equal to, and hopefully both sides are the same. If they are the same, that means your answer was correct. If the two sides are different, that means something went wrong. Probably you have the wrong value. Maybe your check was wrong. So, for example, for this one here, 3x plus 1 equals 16. We talked about how we have the different trays. If I solve this and well, say I got the answer x equals 5. Okay. The thing about solving equations is you can always check your answer. Now, I never feel 100% confident until I check the answer. I might be pretty confident about what I did, but until I actually check the answer, I'm not 100% certain. So the way you do that, say I got the answer x equals 5, or the solution x equals 5. The way we check that is I say, okay, if x equals 5, this side here would be 3 times 5, which is 15, plus 1 is 16. Okay, and then I go over to the other side. Well, it's just the number 16. So if x is equal to 5, the left side 16, the right side 16, that is definitely true. 16 equals 16, and I know my answer of x equals 5 is correct. If I got some other answer, say I got x equals 2. If I plug x equals 2 into the left side, I get 3 times 2 plus 1. 3 times 2 is 6, plus 1 is 7. So I get 7 on the left side, 16 on the right side. 7 does not equal 16, so therefore the solution I plugged in was incorrect. Okay, so that's the way we check our answers. And there'll be some examples on doing that later on in this lesson. Okay, now I'm dividing solving equations for the course into 2 lessons. So the first lesson, if you remember the name, it's 1- and 2-step equations. So what does that mean? It means if it's a 1-step equation, I really only have to do one thing and I'm done. Okay, so 1 step is quick. Well, just one, I'm going to do something to both sides and I'm done. Okay, sometimes it's going to be a 2-step equation where you have to do 2 separate things to both sides and you end up with your solution. So that's what we're going to cover today. Now, unfortunately, not all equations are 1 or 2 steps. Sometimes it's more complicated, and that's what we'll be looking at in the next lesson, lesson 2. And I have a very lovely step-by-step approach to basically solving any type of equation. But for today's lesson, we're just looking at 1 and 2 steps. Okay, so the first page here, page 2, is looking at one-step equations. Okay, and you'll see why they're one step once we start doing the examples. So if we keep thinking about that scale strategy, where the equation is a scale, we have to do the same thing to both sides. So to solve a one-step equation, you ask yourself what math is being done to the variable. And we'll be talking to ourselves through this process. So in all the examples I've got on this lesson and the next lesson, I'm only using the variable x, but by all means, you could be using any letter that's available. I just use x to be a little more consistent, but I could have easily changed the x to a, you know, an S or a W or an A. It doesn't really matter. Okay, so I'm just trying to use the same letters so it doesn't confuse anybody. So what we're going to do for example 1, I've got 10 questions here. These are all one-step equations. So what we're going to do is we're going to state what needs to be done to both sides to get the variable by itself. And then we're going to perform that on both sides. So let's start with x plus 5 equals 12. So that's our equation. You can see left side equals right side. So what I mean by ask yourself what's being done to the variable, kind of look at the x and imagine that's me. What's happening to me here? Well, I'm having 5 added to my value. I have to do the opposite of what's being done already. So if I'm having 5 added, well, the opposite of adding 5 is subtracting 5. So if I subtract 5 from this side, well, remember the scale approach, I've got to also do it from this side too to keep the equation balanced. So what are we going to do to both sides? We're going to subtract 5. So in this case, before I actually do any math, I'm going to state what that one step is going to be, and then we're going to do it here. So if I'm going to subtract 5, I'm going to kind of do it the longer way just to explain what's being done. So I got x plus 5, and then I subtract 5, which I said I would do. And then over here I've got 12, and I'm also subtracting 5. Okay, it's very important. To subtract 5, I can't put 5 minus 12. I wouldn't be subtracting 5 if I said that. But you can see here, the minus 5 is how I've changed the original equation. So since I did the same thing to both sides, equation is still balanced. But now, because I did the opposite of adding 5, when I simplify what's on this side, I can see the plus 5 minus 5, they actually cancel each other out because they combine to be 0. So x plus 0 is just x. So I've got x equals, and then I just do the math here. 12 minus 5, well, that's 7. Okay, and x equals 7 is my solution. And how do I know that's right? Well, remember how I said you could just go plug it back into the original equation. So if I change the x to 7, 7 plus 5, that's 12. On the left side, I've got 12 on the right side. So I know that 100% that this is the correct answer. Okay, so let's go on with some other examples. So in this case, imagine you're the x. What's happening to the x? It's having 5 subtracting 5 from it. So what's the opposite of subtracting 5? That would be adding 5. So that's what we're going to do for this question. We're going to add 5, and of course we're going to do it to both sides. So I'm going to write out x minus 5, and then the plus 5. And then the right side was 3 before, and I'm going to add 5 to that as well. So you can see again, I'm just adding 5 to both sides. And since I did the same thing to both sides, the equation is still balanced and the equal sign still still is correct. They're still equal to each other. So now again, simplify the left side. These minus 5 plus 5 cancel, so I just get x, and then now I have 3 plus 5, that's going to be 8. Okay, and you always know you're done when you get, like I said earlier, the variable equals a number. So in all these cases, it's going to be x as the variable. So we know we're done when it says x equals a number. And it can't be close to that. It's not the same as saying 2x equals 8, okay? It's not the same thing as saying negative x equals 8. It has to be x equals a number. Then you know you're done, okay? So it always has to start with x equals or whatever the variable is, followed by an equal sign. Okay, let's try this one. So this time, what's happening to the x? Well, we're subtracting 1 from it. So let's do the opposite of subtracting 1. That would be adding 1. Okay, so I'm going to add 1 to both sides. Now, after a while, you probably get pretty good at this, hopefully. And maybe you say, well, you know, why do I need to do this? Because I know it's going to cancel out anyways. And maybe I could do this in my head. If you got good math skills and you're confident in your ability to do that, I've got no problem with that. But, you know, sometimes doing this extra little step will avoid some of the common little math calculation errors. So this is always a safer option. But like I said, if you're confident and you want to just say, oh, that's x, and this is going to be, in this case, negative 7, x equals negative 7, you could go right to the final answer right from there if you're comfortable with that, okay? So x equals negative 7, and we could test that by plugging it back in, and yes, it looks like it would work because both sides would be negative 8. Okay, part D here. This time, we're not adding or subtracting something to x, we're actually multiplying x by 2. So what's the opposite of multiplying by 2? Well, that would be dividing by 2. Okay, so that's what we're going to do to both sides. And the way I'm going to show that is not with the divide sign, like the line with the 2 dots. I'm going to actually make it like a fraction divide. So whatever's on the left side would be over 2. That's the same as dividing by 2. And then the right side would be 20 over 2. Okay, so when we do it this way, when we actually do the division now, well, this 2 will always cancel out with this 2 because we picked the 2 so that they would cancel out. Okay, so we're multiplying by 2 and then dividing by 2. So we're back to where we started from, which would be x. Okay, and then 20 divided by 2. Again, you know, if you're very comfortable with your math skills, go ahead and do it. But if you're still not real confident, what I would suggest is try to do it in your head and then confirm your answer by using the calculator. Okay, I'd rather use the calculator and get the right answer, but at the same time, I'd like you to try it in your head so that those skills can improve as well if you find you're struggling a bit. Okay, this one's similar, except instead of multiplying by 2, we're multiplying by 1.1. So the opposite of multiplying by 1.1 is dividing by 1.1. So you notice this time it's a decimal, and that's okay. It could be a decimal, fraction. We've only worked with integers so far, but so this time when we divide by 1.1, don't forget we got to do it to both sides to be consistent. Now, when you work with decimals, it's always a bit more of a struggle. This one here should be obvious. If I'm multiplying by 1.1 and then dividing by 1.1, I'm back to x. But this one, not so sure about. So the one thing I do know about this is I have a negative divided by a positive. So I know the answer will be negative because I've got a negative and a positive. That's the same with multiplication, right? If you have a negative and a positive number that you're multiplying or dividing, you end up with negative. Okay, so on the calculator now we can just do 22 divided by 1.1, and we get 20. So the answer overall is x equals negative 20. And again, you could plug that back in, see if it's correct. Okay, let's go back to the top here. So this time, again, we're multiplying x. This time we're multiplying by negative 4. So the opposite of multiplying by negative 4 is divide by negative 4. So we're always thinking opposite or inverse operations. The number doesn't change. You notice I didn't change it from, so multiplying by negative 4, I didn't change it to divide by positive 4. So I'm not doing anything, I'm not flipping the sign or anything. I'm just using the opposite operation from multiplying. But whatever number is being multiplied with, I'm dividing by that same number. Okay, so now negative 4x divided by negative 4 is equal to 0, which was there before, divided by negative 4, and those will cancel as always, and we get x equals, remember 0 divided by anything other than 0 will be 0. And again, if you're not sure, you know, come up with what you think it is and then actually do it in the calculator, and you'll either be right or wrong. Either way, hopefully you're improving your math skills. Okay, this one here is a tricky one. Let me just move this box out of the way. So this time we are multiplying by a fraction. So does that change things? Well, I'm still multiplying by 2/7 if you think of it that way. X is being multiplied by 2/7. So what's the opposite of multiplying by 2/7? Well, again, I just changed the operation to divide by, and the number is still 2/7, just like the other ones we did. We changed it to divide by, but the same number. Now, if you remember your fractions, and when we divide by a fraction, we never actually do that. We change a divide by for fraction into a multiply. So we're going to multiply by, and if you remember, we can do this if we flip what we're dividing by upside down. So 2/7 would be 7/2. So instead of dividing by 2/7, which we are doing, we're going to multiply by 7/2. It just makes it easier math, I think, in the end. So what does that mean in terms of, so I've got my 2/7 x, and I'm multiplying that by 7/2. So I can actually put that in front, and I'm going to put it in brackets just so you don't think that it's a 72 and a 27. And I like to put brackets in lots of places if it makes this easier to understand. So I also put a bracket around the 2/7. So I'm multiplying these two fractions, and whatever that is goes with the x, multiplies with the x. And of course I have to do the same thing with the 6. So that's being multiplied by 7/2. Okay, and one thing about when I'm multiplying a fraction with an integer, it always makes it easier to understand what's going on. If I change the 6 into its own fraction, so 6, any integer, I can just put that over 1. So 6/1 is still 6. Okay, so if I do that, let's make sure this equal sign is still there. If I do that, now it's very obvious how I'm going to multiply. Okay, a lot of students forget how to multiply 6 times 7/2 because they're thinking, well, maybe I multiply the 6 with both. That would be wrong. But if you see it as two fractions, it's a little more obvious. Multiply the 6 with the 7. So that's 42. And then on the bottom, I've got 2. Okay, now we're gonna simplify that next step. But for now, let's just leave it as a fraction. Same idea over here. 7 times 2, 2 times 7. Well, that's the same number. That's 14/14, x. And now I'm going to simplify this. So 14/14, that's 1. So, I'll just put my answer over here. X is equal to 42 divided by 2 is 21. Okay, and this one's a little harder to test, but it would be 2 times 21 divided by 7, and that is equal to 6. So we can confirm that that works. Okay. The next one, we have a fraction. Well, it looks like a fraction. What's happening is we've got x over 6. The whole thing is negative. Now, it can be a little confusing if you're wondering, well, where do I use the negative sign? Okay, so for something like when you're solving an equation, I would probably avoid putting it with the x. So I'm actually going to just slightly modify this equation so it becomes a little bit more obvious what we're going to do. So instead of negative of x over 6, I've actually applied the negative sign just to the bottom. Okay, so that basically reads x divided by negative 6 is equal to negative 7. So what are we doing to x? I just said it. We're dividing by negative 6. What's the opposite of that? That would be multiplying by negative 6. So we're going to do that to both sides. So if I multiply by negative 6, it actually only goes on the top. So multiply the x with negative 6, I get negative 6x. And the negative 6 was already there before. And then I've got negative 7 times negative 6 on the right side. So I've got to clean this up a bit. The negative 6's cancel each other out. So I'm left with x equals, and then negative 7 times negative 6, it's going to be positive 42. Okay, so let's try a couple more. This time we've got an equation, x is being multiplied by negative 99. So how do I undo that? I'm going to divide both sides by negative 99. So I can write that as this. It's important to keep the sign there. Okay, so if that's multiplying by negative 99, you must divide by negative 99 so that the negatives cancel each other out. And then over here I've got 396, and I'm also dividing that by negative 99. Okay, so now when I simplify this, I can see those two will cancel. Okay, and when I divide this out, I would definitely use a calculator, unless you're really confident. This actually works out to a nice number. This is going to be negative 4. Okay, last one of the one-step equations. So this one looks fairly easy, but it gives students a lot of trouble. So I wanted to cover something like this to show, well, how do we handle something like this? So negative x equals 0. It almost looks like that's the solution, but if you remember, I said you don't stop until you've got x equals, and this is not the same as x equals. But what does negative x actually mean? You could think of it as subtracting x, or you could also think of it as x times negative 1, and that's the way we're going to think of it for this. So I'm actually going to change the equation just this time. Instead of negative x, I'm going to put negative 1x. It actually has the same meaning, but now when we look and say, well, what are we doing to the x? You can now say we're multiplying it by negative 1. So what are we going to do to undo that? We're going to divide both sides by negative 1. So when I do that, you can see again, those two numbers cancel. So I get x equals, and then 0 divided by negative 1 is 0. Okay, so those are some good examples of one-step equations. So again, just a reminder of what we're doing. You always ask yourself, what's happening? What are we doing to the x? Okay, and then we do the opposite. So if we're adding 5, we subtract 5. If we're subtracting 5, we add 5. If we're multiplying by 2, we divide by 2. Multiplying by 1.1, divide by 1.1. So hopefully you see, I know it's very monotonous going through this, but if you if you see the pattern here, it becomes a little bit easier. Okay. Okay, so let's, we've covered off one-step equations, so we're going to look at two-step equations. So we've got 8 examples to do. So let's talk about our strategy for this. So we're going to use the same idea. So let me just kind of read through this with you. So what we're going to do is still think about the equation like a scale. We're going to do the same thing to both sides of the equation. So since this is a two-step equation, it means, well, first of all, it means we're doing 2 things to x in the equation. So to undo those 2 things, we have to also do 2 steps. Okay. Now, so we're going to do the opposite operations to both sides of the equation. Now, here's the important part that this is usually the biggest cause of mistakes. Well, first of all, usually when you have a two-step equation, you have a multiplication or division and also an adding or subtracting. You have one of these and one of these. Now, you might ask, well, which one do I do first? So the best way to think about this, I always use the the analogy when you put your shoes on in the morning. Okay, you got your shoes and your socks. You put your socks on first, and then you put your shoes on. But when you undo that in the evening, when you take your shoes off, you do that process in the opposite order. So if I put my socks on first and my shoes on second, when I take them off, I have to take the shoes off first and the socks off second. So the order changes. So whatever I did most recently to the variable, I have to do that first and then do the thing I did at the beginning as our second undo. So hopefully when we look at this, it'll make more sense. So again, we're going to write down what we're going to do, but this time there's going to be 2 steps. So for example, I might say I'm going to add 5 and divide by 2, something like that. Okay, so again, start off by thinking, okay, what's happening to the x here? And you have to do it in the right order, the order that BEDMAS says. So you look at the x and you can kind of see we're multiplying by 2, but we're also adding 1. But which one actually happens first? Do you add 1 to x first, or do you multiply with 2? And BEDMAS tells you have to do the multiply first. So what we're doing to x here is we're multiplying by 2, and then we're adding 1. So if I want to undo that, like the shoes, I have to do the opposite of adding 1 first. So the opposite of adding 1 is subtract 1. Okay, and then I have to do the opposite of multiplying by 2, which is divide by 2. Okay, now if you've got these instructions all ready for you, now you just have to follow them. Okay, and I've got it in the right order, which will make it, you'll be successful if you do it in this order. If you try to do it in the other order, you won't solve the equation. If I tried to divide by 2 first and then subtract 1, it's not going to work out well. So let's do the first step. We're going to subtract 1 from both sides. Okay, so you can see my subtract 1 again. So if I simplify that, I've got my plus 1 minus 1, they cancel. So I've got 2x is equal to 7 minus 1, which is 6. Okay, so I've done that step. Now I'm going to divide both of these by 2. So I've got 2x over 2, or divide by 2, equals 6 divide by 2. And, we've seen questions like this in the one-step equation. So now we just, 2 divided by 2 is 1, so x equals 3. Okay, so you see the difference. We have that one extra step, and we have to make sure we do it in the right order. It's almost always going to be an add or subtract as your first step, and then a multiply or divide as your second. It's not all the time, but most of the time. So again, you'll know for sure if you ask yourself what's happening to the x. What happens first? What happens second? Okay, you don't have to worry about the other side, just what's happening on the side with the x. Let me just fix this box here so it's not covering the question. Okay, now this one here. So if you imagine, okay, what's happening to the x? First we're multiplying by -3, then we're adding 12. So we have to undo the adding 12 first. So the opposite would be subtract 12. And then we would do the opposite of multiplying by -3, which is divide by -3. Okay, so first we're going to subtract 12. -3x plus 12 minus 12 is equal to 3 minus 12. Okay, plus 12 and minus 12 cancel out, left with -3x. And over here we got 3 minus 12, that is -9. Okay, so we did the subtract by 12, cleaned it up. Now we're going to divide by -3. So both sides, and don't forget it's got to be negative, otherwise it won't cancel the -3 that was already there. So we get x equals negative divided by negative. Well, that's always going to be a positive. So then you just have to worry about 9 divided by 3 is 3. Okay, and again you could check, make sure you're right. -3 times x would be -3 times 3, which is -9. -9 plus 12, that's 3, and that's the same on both sides. So you know you're right. Okay, let's try this one here. So in this case we're multiplying x by 0.5. And then we're adding 3, so we have to undo the adding 3 first, since it happened last when we did the operations in the equation. So we're going to subtract 3 first, and then we're going to divide by 0.5. 0.5. Okay, so subtract 3. I got 0.5x plus 3 minus 3 is equal to 11 minus 3. Okay, if we want to clean that up, our plus 3 minus 3 cancel out, so we got 0.5x equals 11 minus 3 is 8. And now we're going to divide both sides by 0.5. Now I've always been doing it as a second step here, like actually rewriting it out to show you the different steps. Now if you want to, you could just do a divide, put your division bar now and put a 0.5 underneath. I'll just keep using this approach so it's more obvious as to what I'm doing. 8 divided by 0.5. Okay, now the 0.5's cancel out as always, so we're left with x equals. Now this, I know a lot of people, when you try to do this in your head, you're thinking, a lot of people think the answer to that is 4. Well, 8 times 0.5 would be 4, but 8 divided by 0.5 is not. It's actually 16. So that's a calculation. Sure, try it in your head, see what you think it is, and then do it on the calculator and confirm or correct your manual calculation. Highly recommended you try it yourself, but always back it up with a calculator answer as well. Okay, this one here, hopefully we're getting the hang of the steps. Okay, so to undo this, first of all, I'm going to undo the subtract 4, so that's add 4. And then I'm going to undo the multiply by 1.2, which is divide by 1.2. Okay, if we actually do that now, 1.2x minus 4 plus 4 is equal to 20 plus 4. Okay, the minus 4 plus 4's cancel, so I have 1.2x is equal to 24. And again, well, maybe this time I'll just do the divide by 1.2 on both. This is what I meant by doing this in one step. but I did want to show you, that we did this first and then we did the division. Okay, so when we do the division, those cancel out, and we get, now this again, decimals always lead to bad calculations for some reason. So actually try it out. See what you think it is, and then do it on the calculator and check the answer of 20 to what you thought it was. Okay, let's go back up here. This time we're going to do some divisions instead of multiplications. So how do we undo this? Well, first we undo the subtract 1, which is add 1. Then we undo the divide by 2, because x is being divided by 2 here. So the opposite of dividing by 2 is multiply by 2. Okay, so add 1 first. So we get x over 2 minus 1 plus 1 equals 5 plus 1. Those cancel out. So we have x over 2 is equal to 6. Okay, so I haven't been really checking these off, but it's up to you if you want to do that. So now we multiply by 2. So remember, when I multiply by 2, it's like 2 is the same as 2 over 1. So if I multiply this fraction by 2 over 1, it's only the 2 only multiplies with the top. So I have 2x over 2 is equal to 6, and I have to multiply that by 2 as well, don't forget. Okay, and when I do that, you can see the 2's cancel. So I have x equals, these should always cancel, otherwise you did the wrong operation here. You should never end up with anything other than just x after the second step. And then we multiply the 6 and the 2 and get 12. And that's our final answer. Okay, let's try this one. So if you're thinking x, first we're multiplying it by negative 1/5. Then we're adding 5, so we have to undo the adding 5 first. So that would be opposite of adding 5 is subtract 5. Opposite of dividing by, the opposite of multiplying by negative 1.5 is dividing by negative 1 over 5. I think I said 1.5, negative 1 over 5. But remember, this is a fraction. So if we're dividing by a fraction, we're going to switch that to a multiply. So it's going to be multiplied by the opposite of this. So the opposite, if I flip this upside down, I could either say, well, the opposite of that's going to be negative 5 over 1. It doesn't really matter where I put the negative sign. Now, since I changed the divide by negative 1/5 to a multiply by negative 5 over 1, I'm going to remove that. I don't want to actually do it twice because I changed this into this. So these are my two operations. First thing, add subtract 5, negative 1/5 x plus 5 minus 5 equals 4 minus 5. So the 5's cancel. And 4 minus 5 is negative 1. And now I'm going to multiply by negative 5 over 1, which is really the same as negative 5. So for this, I'm going to multiply by negative 5 over 1 times negative 1/5 x. So this is what was there already. Just multiply it by negative 5 over 1. And then equals negative 1 times, and this, since this is an integer, I'll just use negative 5 to make it easier. Okay, this looks a bit messy, but if you actually multiply it out, I get 5 over 5. 5 over 5 is just 1, so this turns into x equals, because those actually cancel each other out. And then over here I get negative 1 times negative 5 is 5. Okay, so I actually did this step and then I did that step. Okay. All right, next step, next question here. 2/3 x plus 11 So how do we undo that? Well, first we subtract 11, because that was the last thing we did when we actually worked through the left side. So we undo it the opposite order. So that's subtract 11, and then since this is multiplied by 2/3, we would divide by 2/3. But again, we would change this into a multiply and then flip this upside down. Multiply by 3/2. Okay, so again, cross that off because these two are actually the same thing, but it's much easier to do as a multiply. Okay, so first we subtract 11 to 2/3 x plus 11 minus 11 equals -1 minus 11. The plus 11 minus 11 cancel, so I have 2/3 x. -1 minus 11 is -12 over there. So I did the subtract 11, multiply by 3/2. So again, when I do that, it'll be 3/2 times 2/3 times x equals, this time let's write the -12 as a fraction. -12 over 1 times 3/2. Okay, and again, this will work out to 6 over 6. 6 over 6 is just 1, so that's just x equals. And then this side, if I multiply the top, that's -36. And if I multiply the bottom, that's 2. So -36 over divided by 2 is -18. You could do this in a couple more steps just to make it more meaningful to you, avoid mistakes. I'm just kind of running out of room, so I probably would do this in an extra step with an extra step. But if you're confident in your math, that would be fine. Now, here we've got -x plus 2 equals 12. So this actually looks a little easier than some of the other ones. So how do we undo this? First we undo adding 2, so that would be subtract 2. Now, what's happening to the x here? If you remember the last example in the first page, so remember we had -x equals 0. So what we did, we talked about how -x is really the same thing as -1x. Okay, so I can do the same thing here. So I'll write that as -x plus 2 equals 12. So now we can think, okay, first we subtract 2, and then since actually I forgot to put the 1. Since what we did was multiply by -1, the opposite of that would be divide by -1. Okay, so let's subtract 2. So that'd be -1x plus 2 minus 2 equals 12 minus 2. Okay, plus 2 minus 2 cancel. So I just have -1x. 12 minus 2 is 10. Okay, and now what we do is divide by -1. So I'll do that from my previous answer. And you can see the -1's cancel. And I've got 10 divided by -1. Well, that's going to be -10. Okay, so hopefully that's lots of practice at two-step equations. The big thing, the big difference, obviously it's got 2 steps instead of 1 compared to the one-step equations. But the other thing that's really important is the order that you do those 2 steps. And the order will be the opposite order that things were being done to x in the equation. So if you want to just talk your way through it. Think of yourself as the x and say what happens to me first, and then what happens to me second, and then you do the opposite operation in the opposite order that you did them originally. Okay. Okay, so that's 1- and 2-step equations. Now we were doing some of these already. So example 3 is just checking your solutions. And we've been doing quite a few of these kind of along the way. Not so much written down, but just kind of working out in our heads. So I want to do some formal checks. So this says do 3 equations from example 1, 3 from example 2. So I'm going to go back to example 1, and I'm just going to pick 3 equations. Let's do B. So B was, so I'm going to put the actual equation and then the answer we got. So if you remember, 1b was negative 3x plus 12 equals 3. And we think we got the answer, solution x equals 3. Okay, and then another one we could do would be, let's do E. So E was x over 2 minus 1 equals 5, and we believe the answer was x equals 12. So we're going to check that. I'm just going to write them all down first, and then we'll go through it just to save some time. Okay, let's pick another one from example 1. Let's go with G. So good. G, that was 2/3. Actually, no, I'm doing this in the wrong order. You can see these are 2-step equations. So I started with the wrong page. So let's do those ones first and then go do some easier ones from the first example. So G might be the hardest one of all of them. 2/3 x plus 11 is equal to negative 1. And we got the answer negative 18. X is negative 18. Okay, so how do you formally check these? Make sure you got them right. Well, I would write it out exactly like this, the original equation, followed by what you think the answer is. You know, you could put that in a box or a circle just to make sure it's separate. Don't put it right up beside it, because then you get confused as to where's the equation. So what we do here, everywhere we see an x, we're going to replace it with a 3. So there's only one x, so it's going to be 3, and negative 3x means we're multiplying, so it's going to be negative 3 times 3. Okay, so I've just replaced the x with a 3, and everything else is just as before because there's no more x's. And now we just evaluate this. We calculate the left side and the right side. So negative 3 times positive 3, that's negative 9, plus 12 equals 3. When I do this, I'm not solving it again. I'm just putting the answer in and then seeing if the answer works. Okay, so I'm just evaluating the left side. The right side, I don't have to do anything in this case because it's all just one number. But then this, I have to combine these two, so I get a 3. A 3 equals 3. Now, what you want to see is not the number here doesn't really matter. The fact that it's the same here is just a coincidence. But what you really want to see is the two numbers are the exact same. So 3 equals 3, that's a true statement. Okay, if I got something like 2 equals 3, well, that's not true. So if that wasn't true, then this can't be the correct answer. So when I get the same number, a number equals itself, then I know that the solution was correct. So I know that x does equal 3. I'll put a check mark there and know that we got the right answer. This one here, x over 2 minus 1 equals 5. So I'm going to replace the x with 12 because we think that's the correct answer. So this time I don't need brackets because the 12 is being divided by something. Okay, so 12 over 2, that's 6. 6 minus 1 is 5. 5 does equal 5, so that means our solution of x equal 12, that is correct. Okay, let's try this one here. So x is negative 18, we believe that's the right answer. So 2/3. Now I could put just negative 18 in brackets, but I can see that I'm going to be multiplying that with a fraction. So just to make it easier for you guys, I'll write this as a fraction. So I just put that over 1. So negative 18 over 1. And if I really want to, I could put brackets around here. Don't have to, but sometimes it makes it easier to work with. Plus 11 equals -1. That was already there. So now we multiply the two numerators and the two denominators separately. So we get -36 over 3 plus 11 equals -1. -36 divided by 3, that's -12. And -12 plus 11 is -1. And -1 does equal -1. So that means our answer of x being -18 was correct. All right, so we got the hard ones out of the way. Let's do a couple from example 1. So these are just the one-step ones. These will be a little bit quicker. Let me just find where I did those. Okay, so if you remember, here's our questions here. So I'll just pick some random ones here. Let's do, start off with, I don't know, B again. And let's do, I don't know, E, and then finish off with H. Okay, so B, if you remember from our work that we already did, that original equation was x minus 5 equals 3, and our answer was x equals 8. So these ones will be quicker, I think. So I replaced the x with an 8, and 8 minus 5 is 3, and 3 does equal 3, so that means our solution was correct. Okay, E was 1.1x equals -22, and our answer was x equals -20. Okay, so let's replace the x with -20. So 1.1 times -20 is equal to -22. So when I multiply 1.1 with -20, I actually get -22. So I definitely use your calculator for that, and those two numbers are the same. Notice this time, every other case, I think, these numbers had nothing to do with the answer. It was just a fluke the first time. Okay, so all that matters is the left side equals the right side. Is that true? And if the numbers are the same, yes, it is true. So if that's true, then this is also true. And that means our answer was right. Last check we're going to do is we have -x over 6 is equal to -7. And our answer for that was 42. X is 42. So if we replace the x with a 42, okay, and we do the division, -42 divided by 6 is -7. I'm not just writing that because it's over here. I'm actually doing the calculations every time. It's almost good just to kind of cover up the other side while you're doing each side, so that you're not tempted to just make them the same. You actually have to go through the calculation. So since that's the same, that means x does equal 42. Okay, so this lesson covers one and two step equation solving. Again, I want you to think about solving equations. Always think about that scale. The equation is like a scale. You've got to do the same thing to both sides, otherwise the scale tips. If the scale tips, the equation's not equal anymore. Okay, so, and what do we do when we're solving equations? We do opposite operations. So hopefully, if you want to go back through some of those examples, I have assigned some homework questions for 1 and 2 step equations, and then some checking equations where you actually have somebody's solution to a question, and I want you to check it and tell me if it's correct or not. And when you do those questions, make sure, I don't want you to just solve it yourself. when I ask you to check it, it's really doing just this process. Plug the solution back into the question and see if the two sides are still equal. Okay, so that's it for lesson 1. Lesson 2 will be the multi-step equations, the equations that can look really scary. But I'm going to be teaching you a 6-step process that I could give you any equation, any linear equation, and you'd be able to solve it just by going through those steps. So it's a pretty nice approach. It takes a lot of the frustration out of what do I do next. Okay, so that's it for today. Have yourselves a great day. We'll see you in the next lesson.